In this lesson, we're going to look at what happens when you change a figure proportionally, which means that all the dimensions of your figure are multiplied by the same scale factor to create a similar figure. So here's where we're talking about enlarging a figure or reducing a figure down. But one thing you need to note is there's no distortion in the shape. It's just a smaller or larger copy of itself. Like these two pyramids, these have been changed proportionally, and we can see that if we compare the height to the new height. Let's do that with a fraction. The way you do that is you take the new and you divide it by the old measure. So it's new compared to old. So this would be 15 compared to 10 in a fraction, which divides out to become 1.5. The height, in other words, has been multiplied by 1.5 to get the new height. Now the same needs to happen with the base length. So this base length of the square here was 6.7 and now it's 10. Let's see if that works. So comparing the new 10 to the old 6.7 and dividing that out, we get a 1.5 again. So this has also been multiplied by the same scale factor of 1.5. And because we use the same scale factor, we just get this enlargement with no distortion in its shape. So what our specific questions are going to be will be like this one. What would be the effects on the perimeter and the area if we change the dimensions with the same scale factor? In this case, we are doubling it. You don't have this in your notes, but just follow along with one way you could do this problem. I call this method the brute force method. This means we're just going to tackle it by doing what we can to figure out the new dimensions. So here is a rectangle, and we might double the dimensions and make it look like this. Notice everything's been multiplied by 2. And then you might go ahead and find the perimeter of the rectangle by adding the sides up, which gives us a total of 20 centimeters. And then you can compare it to the new rectangle by adding its sides up, which gives us a total of 40 centimeters. And so what happened to the perimeter? Well, the new perimeter is 40 compared to the old 20, so you might say that the perimeter was doubled. Does the same thing happen to area? Well, calculating the area of the smaller one is length times width, which gives us 21 square centimeters. And for the new rectangle, it's 14 times 6. That's the new length and width, giving us 84 square centimeters. So did the area double? Well, if you do the calculation, you get the new area was 84 compared back to 21. When we divide that, we get 4. In other words, the area is 4 times as large. And the perimeter, remember, the perimeter was twice as size. So doubling the dimensions doubled the perimeter, but it made the area 4 times bigger. Why is that happening? Well, that was the brute force method, and there was a little bit of calculation involved, and there would be a lot more involved with a more complex figure. So I want to teach you a shortcut, and this shortcut is using the scale factor itself. Let's see how we can make these problems a lot easier. One thing you need to know is some vocabulary. When they say words like dimensions or halved, doubled, or tripled, you need to know that that translates into a scale factor. Halved, of course, would be 1/2 for a scale factor. Twice or doubling the dimensions would be a scale factor of 2. Tripling is 3, quadrupling is 4, and there's more than this, but just get familiar with the flavor of those words. All right, this shortcut method acts this way. You ask yourself as you start, how many dimensions are in the measure? How many dimensions? So, for example, if you have a perimeter question, how many dimensions is perimeter? Perimeter is just a length or a one-dimensional measurement. Also, circumference would be the same way. The units of this type of measure are just plain old inches or centimeters, for example, one-dimensional basic units. Now, area is a different story. The areas are two-dimensional measurements. So how many dimensions are in a measure for area? 2 would be the answer to that. And that can be remembered with the units. The square centimeters and the square inches, those are both two-dimensional. And then, of course, we know that volume is three-dimensional. So any volume question is a three-dimensional question. You can remember that with cubic inches and cubic centimeters to help you remember. So how many dimensions are in the measure is either 1, 2, or 3, depending on what you're doing. That's the first question you have to answer. The second thing to know is that you want to apply the scale factor for each dimension in the measure. Here's an example to show you what that means. You apply a scale factor for each dimension in the measures. So let's say that you want to know how the surface area is affected by tripling the dimensions. First of all, surface area is a two-dimensional measurement. And so that means that you want to apply the scale factor twice since it's two-dimensional. And we said we were tripling, so that would mean the scale factor is 3 and we would use it twice in our calculation. Let's do an example of this new way. Pause the video and do part A on your own. This is just calculating perimeter and area, which you already know how to do for the trapezoid. Get those down on your paper and then come back to me and we'll go from there. Okay, if you calculated those right, you would have 58 centimeters for perimeter and 152 square centimeters for area. Now let's go to part B and see how we can scale this. Part B asks us to find the new perimeter if the dimensions are halved, and then again if they're quadrupled. So this is how it works. First question is, what type of measure is perimeter? 1 dimension, 2 dimension, or 3? And since it's just a length, it's 1 dimensional. And so to get my new perimeter, I take my old perimeter of 58 and I multiply by 1 of the scale factors because there's only 1 dimension in perimeter. So my scale factor is 1/2, and that goes in right there, and that means my perimeter got cut in half, or 26 centimeters is the new perimeter. If I'm quadrupling, the same thing applies. So my new perimeter would be my old perimeter of 58 multiplied by 1 scale factor. It's 1 dimension, so 1 scale factor would be 4 for quadrupling, and I would get 232 centimeters for the new perimeter, 4 times longer. All right, now how does it work for area? Area is a 2-dimensional measure, so I'm going to apply my scale factors twice. To find my new area, I'm going to just simply write down my old area of 152 and multiply it not once but twice because of the 2 dimensions that we have. Each one was cut in half, so I use 1/2 and I use it again. Half times a half. My new area can be found by taking 152 divided by 2 and dividing it by 2 again. In other words, 38 square centimeters. And finally, if I want to get my new area by tripling those dimensions, I simply take my old area, 152, and I multiply by 1 and 2 scale factors, once for each dimension, each one being tripled, and then I get my new area. 1,368 square centimeters. So to me, that's a lot easier than calculating the areas and the perimeters over and over and over again. That's how the scale factors work. For some questions like this one, they won't necessarily ask you how big a measurement is, but instead they'll ask you to compare two measurements. How does Pyramid 1 compare back to Pyramid 2, both in surface area and volume? We can see easily that Pyramid 2 is bigger, but that's not exactly specific enough. Look back to the beginning of this lesson and you'll see again that we found that our scale factor that takes us from Pyramid 1 to Pyramid 2 was 1.5. All dimensions were multiplied by 1.5. So how does that affect surface area and volume? Here's our shortcut. Surface area is a 2-dimensional measurement, and so that means that the scale factor applies to 2 dimensions. And all we have to do is make room for 2 spots to apply our scale factor. Putting 1.5 and 1.5 again, so we apply it twice, we get 2.25. And so what does that mean? Well, that's how many times more surface area we have in Pyramid 1 compared to Pyramid 2. So you might write your answer like this. Pyramid 2 has 2.25 times more surface area. Now before we leave this, remember we were also asked about volume, and volume is a 3-dimensional measurement. So that means that I'm going to apply 3 scale factors to figure out how my volume changes. The scale factor is still 1.5, but it affects it in 3 different directions. And so multiplying all these together gives me 3.375. And how do I interpret that? Something like, and how do I interpret that number? Well, that means that my Pyramid 2 is 3.375 times bigger in volume than my Pyramid 1. Or Pyramid 2 holds 3.337 times more. Now here's a good reminder before we go into the last examples. One thing to know is that all squares, circles, cubes, and spheres, those are special because they're always similar. No matter what, if you take a circle and you make it bigger, then it's going to be similar to the smaller circle because there's no distortion that occurs. It can't have any distortion or it wouldn't be a circle anymore. The same goes for spheres, cubes, and squares. And so why is this important? Well, let's take a look at this example. In this example, we are going to compare what happens to perimeter and area of a square if we triple a side length. So we take a square and then we make it bigger by making it 3 times the side length. So our scale factor is times by 3. Well, it's important to understand that not just one side was times by 3, but all sides were times by 3. So if we follow our little shortcut, starting with perimeter, perimeter is a one-dimensional measurement, and therefore the perimeter would just be one scale factor bigger. So 3, of course, is 3. I'm going to use it once, and therefore the perimeter is 3 times bigger. But what happened to the area of the square? The area is also asked for, which is a two-dimensional change, so that means the scale factor not only applies to one side, but applies to both sides. Both sides were tripled, so we multiply by 3 again to get the change. And the change is 9 times bigger. So the area is 9 times bigger. With balls, the same thing applies. Here we have the diameter of a baseball is approximately 1/3 the size of the diameter of a soccer ball. If it takes 995 square inches of leather to cover a soccer ball, how much leather is needed to cover the baseball? If we're covering the soccer ball, then of course that's the surface area, which is a two-dimensional question. So I'm going to write down my current surface area for the soccer ball. The soccer ball takes 995 square inches of leather, and then I'm going to multiply by 2 scale factors. 2 dimensions, 2 scale factors. Well, what is the scale factor? They told us the diameter all the way across this ball compared to this diameter is 1/3 the size. So therefore my scale factor is 1/3. That I'm going to put in to my two-dimensional spots. So 1/3 and 1/3 again. So if the soccer ball is 995 square inches, then that means I multiply that by 1/3 twice, or divide by 3 twice, and I get 110.5, and that repeats. This would be square inches needed for the baseball. And finally, how does the volume compare? So volume is a three-dimensional question. How does it compare? We don't know the volume of the soccer ball, but they're just, again, asking us to compare them. So we would apply scale factors. And I apply it 3 times since my question is a three-dimensional volume question. Putting in my scale factor of 1/3 for each of these and multiplying it together, that gives me 1/27. 1/27. So that means that the baseball has 1/27 of the volume of the soccer ball. I hope this helps you a lot. These should be some quick and efficient types of questions for you, and we're going to practice them a lot in class. So I'll see you later.